All right, so the last topic I want to cover with respect to object-oriented programming is the principle of composition. And what it amounts to, is taking one class and putting it inside of another, or objects of a class and putting them inside the definition of a class. Let's just get into it and see how it works. So, the basic of it is objects can be member variables themselves. So this creates what we call the has-a relationship, in the sense that a course has students, a store has goods, and a business has departments, and those departments have their own employees. So if we were to create a course class, that would contain a list of students. So, class definitions can be nested inside each other. So you can create a class within a class, but this is not the most recommended practice. It's better to create them separately and then nest them inside each other that way. If you create a class within a class, instead of just creating an object of a class within its containing class, this can limit reusability and also readability. So it's generally not recommended unless that component is intrinsic to the class in some inseparable way. So looking here, we have a gradebook class which contains a list of students. And then we have our student class. Each student has a name and a grade. And each of these has their own stringification here. So if we look at our student class, if we call dunderRepr, it creates a repr with self.name and self.grade that has been cast to a string. And then when we call our repr function under gradebook, we call repr for each student. So we say for student in self.students, repr plus equals repr student plus a new line character. And then of course we just return. And then we see we have some sample data here. And we are going to do just that. We're going to improve our player character by making its inventory not just a list of strings, but a list of objects. So, how we're going to do that, we're first going to create our class. We're going to call it item, or inventory item. And we're going to do our def init self name quantity. We know how to do this at this point. Self.name equals name. Self.quantity equals quantity. And that'll be all. And now we do def string as our dunder function. Give it cephal again. And now we're just going to say toString equals self.name plus space with an X plus string self.quantity. And I want to point out that you're not just limited to a number, but you're not just limited to dunder functions. You can make any kind of function you want in your classes And we'll do one more example making some custom functions instead of just defining these pre-existing ones in our final part of this group of lectures. We return our toString. Oops. There we go. Make sure that didn't do any imports. It most certainly did. Get rid of those. All right, so we have our inventory item. That's a very basic class. Now we're going to change this up a little bit. So we're going to do the same sort of error check. Actually, no, that's not necessary. We can leave this completely alone. Watch how this transforms just because we are feeding it different data. We can change the data type of self.inventory without actually changing this class. The only thing we need to change is our inventory, is how we print our inventory, which we're going to kick this out, and we're going to say for item in self.inventory colon, and we want to say toString plus equals str item plus a new line. Okay. Now we're going to create a list of inventory items before we create our player character. So in this space here, we're going to say player inventory equals. Now we're going to create 3 items. We're going to say inventory item potion 10. Oops, that's not how we want to do it. Let's just copy this element, drop down to the next line. Inventory item, we'll say antidote. We'll say 5 of these. Drop down next line, get rid of this comma. We only want 1 item, and we'll say they have 2 smoke bombs. So we have a simple inventory of 3 items. We're going to pass this inventory list into our third member variable here, player inventory. Now, let's run and test it, see if we run into any issues. And here we go. We do need to make some slight modifications here, so let's do just that. We'll fix this up. So we want to, first off, we want to drop down another \n. And we say toString plus equals. We got to do this a certain way, get a little creative. So we want our inventory to be double tabbed out. So we don't need this extra line. We're going to say toString plus equals, whoops, tab, and then it'll print the item, and then new line. Let's see if that fixed what we wanted to, the way we wanted to do it. Kind of. It's not the neatest, but it does work. And this would involve a fair bit of trial and error, just trying to learn exactly how it's going to look. If you were doing this with a user interface, it wouldn't be nearly as much of a problem. In fact, I think I can fix this. Let's try one more thing here. Oh yeah, just do another new line, Scarlet. Much better, much better. So we have our character named Fiera, is a tiefling, has 120 hit points, and her inventory consists of 10 potions, 5 antidotes, and 2 smoke bombs. So, one more lesson we're going to do, and then we're going to go through and review all of this good stuff here. You can see how this really escalates your code complexity, and we really have to take our time and practice. There's going to be a ton of practice examples in class and in lecture, but we only really have one more official lesson in this course. So stick around for that, where we're going to wrap things up talking about creating some custom functions within our classes. Stay tuned.